graph from Guyton, very important, which will help you to understand inspiration and expiration better. So you can see that this line determines the starting of inspiration, this line determines the end of inspiration, and this line determines the end of the expiration. We know that end of the inspiration is the start of expiration as well. So I'll be starting from this point only. So we can see that the long volume, it increases with the inspiration, gets maximum at the end of inspiration or start of expiration, and then starts decreasing down. Okay. Talking about this is a volume change. So talking about this is about the volume, and why is this graph in this way and why is it in this way. The reason is based on the compliance that I have already mentioned about it in the graph last time. Now talking about this thing, now this graph that you can see is for the alveolar pressure. So if we start with the inspiration, the alveolar pressure decreases, right? The alveolar pressure decreases, but it again starts to increase. Why? Because air starts flowing, and air starts flowing to cause more pressure. Yes, the volume decreases. As in this process, the volume decreases. However, air also starts flowing, increasing the pressure. So, pressure becomes maximum at a point during expiration. Why? Because after this, the pressure start increasing because the volume also decreases. So this part is when the volume decreases, pressure further increases. And then again pressure decreases because the air starts going out. And we can see that the pressure at the end of the expiration is 0 cm of H2O, which is our atmospheric pressure. Okay, so till here it totally makes sense. Now talking about pleural pressure simply decreases and increases during expirations, decreases during inspiration, because pleural pressure here is dependent on the volume of the thoracic cavity. Now, the difference between the alveolar pressure and the pleural pressure is considered to be transpulmonary pressure. You can see that even during the end of inspirations, end of expiration, start of inspiration, there is always transpulmonary pressure. If there was no transpulmonary pressure, then the lungs would have collapsed, because the elastic capacity of the lung, it tries to collapse the lung. The surface tension, that tries to collapse the lungs. However, this pleural pressure, which you can see that is negative, it's about negative -5, it goes off to negative -7. Okay, so this pleural pressure is negative, and this is the one that is responsible for preventing the lungs from collapsing. Okay, I think if you understand this, then it's fine for the pulmonary ventilations.